Backed by student demand, it's Mr. Richards Teaches, applying color-coded strategies to identify and sequence within math. This is your Math 3 5.5 to 5.6 review. I suggest everyone either pause this video and write down your practice or take a screenshot of it. Kicking it off with number 1, we are looking at the logarithmic expression 3 times the log base 5 of A minus log base 5 of B minus 2 times log base 5 of C. The first thing we want to do when condensing to a single logarithm is rewrite with the power rule. Let's zoom on in. All right, we are going to take this 3, that's times the log base 5 of A, and we are going to rewrite this using the power rule. We'll simply do log base 5 of A and set that to the third power. Our minus symbol will simply drop down. Our log base 5 of B, we will again just write down. Nothing's being multiplied in front to use that power rule. And bring down your minus. Ooh, 2 times. Yes, let's give that to a highlight so everyone can see where it goes. The log base 5 of C to the second power. Step 1's out of the way. We will switch over to step 2. Using the quotient rule, we will only focus on the first 2 terms here. So let's zoom on in. Let's focus in on those. All right, we'll lock out. We'll zoom out a little bit. But taking a look at this, log base 5, log base 5, I'm just going to highlight those log base 5s because we will be using that. If they both share it, well, guess what? When we're condensing, we'll write it as 1. So we have our log base 5. What else do we need to do? Well, what do we know this subtraction turns into? Yes, division. So we will take our a cubed here, and I'm going to set it up a little higher because we will be dividing by, and what's left over here is our b. That b doesn't look too great. Let me rewrite that. And then our minus log base 5 of c squared, we will just copy down. Log base 5 of c squared. All right, so step 3, it wants us to multiply the denominator. All right, because we know we need to get rid of the denominator. So we will multiply by b. Let me actually highlight that b in green so we can see exactly what we're using. That's our denominator. We'll multiply there. We'll multiply by times b here. What this does, it's going to cancel those off. So we will just simply rewrite. Our first term is log base 5 of a to the third power. All right. Now we also, again, bring down our minus, and let's go ahead and do our multiplication here. Log base 5 of c squared b. Oh, but what do I do next? I still see a subtraction. Well, we're going to repeat step 2, but with our 2 remaining terms. All right, so let's take a look. Yes, they both do share the log base of 5. Let's just give that a highlight here. We will use that as 1. All right, now again, we know that our subtraction turns into, yes, division. What's left from this first one is a to the third. We're going to set that biscuit on top of the oven. And let me rewrite that. It just didn't look too great for spacing. And it still doesn't look that great for spacing because I'll shift it over a little hair and boom, we will set up what's left, c squared b. Go ahead and circle your answer. So again, if you'd like to pause the video and like to practice that one, feel free. Here you go. Moving forward to number 2. Cruising along to number 2, we will evaluate the log expression, log base 3 of 243. Give a quick pause to write down your practice problem, but this one is all calculator. Let's pull that calculator into play. We will start by hitting the math button right there. We will down key arrow to find our log base and simply hit enter. Oh goodness, yes, we'll put in our 3 for our base. We will right key arrow over, type in 243, simply hit enter. Yes, our answer is 5. Let's get that calculator out of play and go ahead and give that a practice try. And we will move to number 3. On to number 3, we will be expanding the expression log base 4 of 16x to the 5th. Go ahead and pause the video or write down your practice problem. First thing we want to do is apply the product rule. All right, so if we're expanding this, that means they're going to share a component here. Now this log base 4, I'm going to highlight for a purpose, and I'm going to write it down real quick. I'm going to leave it there, and then I'm going to take a look at, the product rule when multiplying 16 times x to the 5th. Well, guess what? That's going to be separated into 2 terms. Our 16, we will write down with our first log base 4, and then we know when multiplying, well, we have to revert back to addition, and if it's sharing that log base 4, I'm going to write that one more time, and then jot down our x to the 5th. We will go to step 2. Evaluate the first term within our calculator. Now the first term we can evaluate because it does not have a variable. Our second term we cannot evaluate because it has a variable, and that variable may be negative or 0, making it undefined. So let's go ahead and go to our calculator. We will hit math again. We will scroll all the way down to our log base, hit enter, put in our 4, right key arrow over, the number 16, hit enter, we get 2. So now we have evaluated our first term there, and we will just copy down our plus log base 4, x to the 5th, and move forward to our third step, which is to apply the power rule to rewrite the second term. All right, so our power rule, we have an x to the 5th power. I'm going to highlight that. Now this 2, I'm just going to go ahead and copy down. The plus will come on down, but this 5 we need to throw in front of our log, so then it becomes 5 times log base of 4 x. Go ahead and circle your answer. And again, try that practice problem. Number 4 is now asking us to solve the equation log base 5 of negative 2x minus 8 equals log base 5 of negative x minus 4. Go ahead and pause the video to jot down your practice problem, and we will go through the motions. We will rewrite using the property of logs. Well, guess what? Do they share that same log base of 5? Let's zoom on in. They sure do. We are just going to get rid of those. We're going to take our negative 2x minus 8, jot that down, set that equal to our negative x minus 4, and then we will just simply solve through. All right, we have an x on both sides. We will add 2x, as we do know now that we need to play the game of inverse operations. Let's do the opposite, plus 2x. Because what we do to one side of an equation, yes, we must do to the other. Bring down our negative 8, bring down your equals, negative x plus 2x still leaves us 1x. Bring down your negative 4. Now we need to get that x variable alone. What's hanging out on the same side of the equal sign is that minus 4. Yes, we will add 4. What we do to one side, we do to both. Negative 8 plus 4 is negative 4. Bring down the equals, bring down your x, and circle your answer. So go ahead, and again, if you'd like to try it, pause it, and go ahead. Pressing onward to number 5, again, we are solving the equation log base 8 of 2x minus 3 equals log base 8 of 5x minus 15. What did we learn from number 4? Yes, we will rewrite using the property of logs. Do they share the same log base of 8? They sure do. Now pause the video and write down that practice problem. All right, so let's zoom on in. What shall we do? Yes, great job, boys and girls. We will get rid of that log base 8. We will pull out our 2x minus 3, drop the equals, and pull out that 5x minus 15. And from here, it's just a simple equation to solve. All right, so minus 2x, again, game of inverse operations. We will be playing the opposites because if one thing is done, we need to undo. Bring down your negative 3 equals 5x minus 2x is 3x. Bring down your minus 15. We need to get that 3x alone. What's hanging out with it? Yes, it's minus 15. Go ahead and add 15, not just to one side, but to both. Love the balance of an equation. Negative 3 plus 15 is 12. Drop the equals. That 3x again will just come on down. Negative 15 plus 15. That is our cancel. And our last step will simply be to, yes, divide. Great job by the 12 or the 3. Yes, it is the coefficient of the variable or the number in front of the letter, which is 3. 12 divided by 3 is 4. And 4 is going to equal our x. I'm freaking out, man. Dude, relax. There's only 6 steps, and yes, it's number 6. We will be solving the equation 4 to the power of 4x plus 5 equals 50. Step 1 is to isolate that exponential term. We will go ahead and highlight that. We want to get it by itself. And what's hanging out on the same side as the equal sign is the plus 5. We will simply minus 5 from each side. Let's go ahead and rock that out. 4 to the power of 4x equals 50 minus 5. The return, Jordan. Thank you. Then we need to take the natural log of both sides. Now that natural log is represented by an ln. So I'm just going to put the ln, throw this 4 to the power of 4x in parentheses, equals again that natural log of ln. In parentheses, we'll drop the return Jordan of 45. Our third step here, we need to use the log property to drop the exponent. So let's go ahead and rewrite this. Ooh, look at that, wouldn't you know? We are going to put that in front of our natural log. So it's going to be 4x. And then from there, we are simply going to rewrite our natural log. Open our parenthesis, put the 4 inside, and set it equal to the natural log of 45. No big deal so far. What do we need to do next? We need to isolate that 4x. And how do we isolate that 4x? Well, if it's being multiplied, we will simply divide. And what are we dividing by? The remainder of what it's being multiplied to, which is that natural log of 4. So let's go ahead and ln times 4. And let's go ahead and do this, our natural log, our ln times 4. And what is this going to do? This is going to cancel those biscuits out. Oh my goodness. We got our 4x by itself. We sure did. And let's just set that equal to the natural log of 45 divided by the natural log of 4. Perfect so far. So 4 steps down, 2 to go. We will calculate the natural logs. All right, so in light purple, what I'm going to do is I'm going to drop the 4x, and I am going to bring down our equals, and then we're going to go to our calculator. All right, we will hit the ln for our natural log. We will type in 45, simply hit enter. I think it wants us to go to the thousandths on every rounding. So 3 past the decimal, so we'll write it as 3.806, and then the tens of thousands is a 6, so we'll write that as 3.807. We will set that over, and again, we'll just go back to our calculator. We will use our natural log, that ln there. Go ahead and give it a hit. We will type in our number 4, hit enter, and again we will round to the thousandths, so 1.386. That 2 is in the tens of thousands, so that 6 is going to stay the same, and we will simply just write it as 1.386. All right, now that 1.386, so here's what I'm going to do. I need to shift this over just a hair. I'm running out of real estate. We do need to find out what that's similar to. So let's go ahead and do 3.807 divided by 1.386 which is similar to 2.746. Ooh, that's 7 in the tens of thousands. We need to round that up to 2.747. 2.747. And what does it say to do here? Just to simply solve for x. So our last step here, what we're going to do is we will divide each side by 4. This will give us our x by itself. It equals, and let's do 2.747 divided by 4, which is going to give us 0.68. Ooh, 67. That 7 is going to round this 6 up, so it's going to be 0.687. Go ahead and circle your answer. And again, guys, try this independently. It will be one of the more challenging ones on the quiz, but you guys got this, zero doubt. Let's go. And for number 7, again, we are solving the equation log base 3 of 7x equals 2. The first thing we need to do is convert to an exponential, so we're going to be looking at this 2. Now, when we convert this to an exponential, we need to use the base of the log. And what's the base of the log? Yes, it's 3. So we're going to just simply rewrite this as our base of 3. And this 2, we just drop to our second power. Now, when we do that, whoa, didn't know, yes, we can eliminate that. Bring down your 7x equals 3 squared. It tells us to calculate the exponential. All right, so we'll just simply drop our 7x because that's not our exponential, and 3 squared is 9. Great job. That 9's, my 9's kind of look like an A. And then our last step will be to simply solve for x. And what shall we do? Yes, we shall divide each side by 7, giving us x equals 9 over 7. Circle your answer, but pause the video so you can take a look at your practice, write that down, and solve. Okay, solve the equation. Log base 7 of x plus log base 7 of negative 9 equals log base 7 of 23. Pause the video to write down your practice problem. All right, step 1, apply logarithm properties. Well, let's zoom on in here. And on the left side of the equal sign here, we have two terms, log base 7 of x plus log base 7 of negative 9. They both share that log base 7. So what we're going to do is apply that property there, so of log base 7. And what's remaining is the x of our first term. And then we know with addition that becomes, yes, multiplication. And what's left behind that log base 7 is that negative 9. Bring down your equals, and let's just rewrite log base 7 of 23. All right, so step 2, we will remove the log bases because on the left side, we have that log base 7. On the right side, we have the log base 7. We're also going to calculate our x times negative 9 while we're doing it. So go ahead and get rid of that log base 7. Go ahead and get rid of that log base 7. X times negative 9 gives us negative 9x. Set that equal to 23. Our last step is to solve for x. And what do we need to do? Great call. Divide each by negative 9, getting our x by itself equals negative 23 over 9. Circle your answer. That's undefined. And go ahead and try that practice. Hello, Olympic Jordan number 9. Solve the equation. Log base 9 of x plus log base 9 of x plus 4 equals log base 9 of return Jordan 45. Step 1, apply logarithm properties. Let's zoom on in. On the left side, we have two terms. They both share what? Yes, great job. It's that log base 9. So let's let them share it and just rewrite our log base 9. Now, behind that, on our first term is just an x. And we know when working with logs, our addition becomes multiplication. Let's open it up. And behind our log base 9 here is simply x plus 4. Let's rewrite that. Let's bring down our equals. Log base 9 of 45. Let's zoom on out for step 2. Remove logs and multiply. Why are we removing those logs? Yes, they are the exact same. They're both log base 9. Now we will multiply x times x, giving us x squared. X times 4 gives us 4x. Bring down our equals and bring down our 45. Step 3 in green. Rearrange quadratic formula. Ooh, we need to get it equal to, yes, 0. And what can we do? Subtract 45 from both sides. Draw our line. Bring down your x squared. Bring down your 4x minus 45. Bring down the equals and set it to 0. Step 4 in orange. Factor quadratic. All right, so when looking at this quadratic, if anyone remembers from Math 2, former past videos, we need two numbers that when multiplied get us to negative 45, and when combined get us to a positive 4. If not, we have to use the quadratic formula. Good for us, we don't have to, we can factor. So we will go with x plus 9 and x minus 5, because we know 9 times negative 5 gives us negative 45, and 9 minus 5 gives us 4. We will set that equal to 0. Now I said just to take the opposite, because we can just flip the signs for x. Because if they were set equal to 0, well, x equals negative 9 and x equals 5. I will circle x equals 5 as our answer, because x equals negative 9 is undefined. All right, that's not an acceptable answer. So x equals 5. Pause the video and try your Olympic Jordan. A 10-piece nugget with fries, please. Solve the equation log base 6 of x minus 4 minus log base 6 of x equals 2. Step 1, log property and convert 2 to an exponential. Let's do it in one swoop, please and thank you. All right, if we're going to convert that 2 to an exponential, well, it has to have the same base of the log. And if the log base is 6, well, let's go ahead and put in our 6, and we will take that 2 and raise it up as its power. All right, and what I mean by the one swoop is, let's just go ahead and get rid of that log base 6. Let's go ahead and get rid of that log base 6. We will take out our x minus 4. And subtraction becomes, yes, division. And what was left here was the x, so we're going to set it over. And we're going to set it equal to. Step 2 in blue, we will multiply or calculate our exponential here. All right, so the x minus 4 over x, we're simply just going to rewrite x minus 4 over x equals 6 squared, which is, yes, 36. Great job so far. All right, step 3, multiply both sides by the denominator. Well, zoom on in. Our denominator is x. We are going to multiply both sides by x to get rid of that denominator. We will cancel those out, times x. What's left is x minus 4 equals 36 times x, which is, yes, 36x. And step 4 in orange will be to solve for x. We need to get that negative 4 by itself since we have an x on both sides. So that plus x becomes minus x. And let's subtract x here, x minus x. Bring down your negative 4 equals the big hurt, Frank Teasy, 35x. How do we get x by itself? Yes, we will divide each side by 35. Negative 4 over 35 equals x. All right, I'm not going to circle that because you might have an answer choice somewhere along this in all of these questions where if your x is negative, it's not a solution because they don't meet the domain requirements of logarithms. So for this one, on the side, I'm just going to put not a solution. and then circle it. But I'm also going to give you time to pause number 10 for your practice. Will it ever end? Yes, after number 12, but this is number 11. We will be expanding the logarithm log base 5 of x to the power of 9 divided by y to the power of 3. We will apply that quotient rule, and we are going to be zooming in. Log base 5. All right, well, wonderful. And we have two terms, x to the power of 9 and y to the power of 3. So let's go ahead and write that first one, x to the power of 9. Oh my goodness, what does that division become? Yes, subtraction. We are expanding. So that log base 5 will write again. And let's drop over that y to the, yes, third power. And number 2, log rule for exponents. I will highlight our exponents. We have a 9 and a 3, and they are going to come in front of the log. So it's going to be 9 times log base 5 of x minus, yes, great job, 3 times log base 5 of y. And simply circle your answer, but please try the practice. Finally! Number 12, condensing to a single log. Let's condense. 5 times log base 3 of x plus 2 times log base 3 of y. First thing we will do is apply the power rule. So I'm going to highlight this 5 in front of our log and our 2 in front of our log, and we will simply make those powers. All right, so let's just go ahead and rewrite log base 3 of x, and let's just make it to the 5th power, plus log base 3 of y to the, yes, 2nd power. Step 2, apply that product rule. All right, so what do they both share? Wonderful, the log base of 3. Let's just go ahead and write that down. And then we know that our addition turns into multiplication. So log base 3 of x to the 5th. And we will multiply that to y squared. Just write it right next to it. Circle your answer. Try your practice. The key will be following soon. And boom, you have your review. So if you tried all of the practice problems or just a few, here is your answer key. You will be looking at number 1. Take a look. You can pause at any time. Number 2, the answer is 7. Number 3, the answer is 2 plus 4 times log base 6 of x. Number 4, negative 3 equals n. Number 5, negative 2 equals x. Number 6, x equals 1.322. Number 7, x equals 16 over 9. Number 8, x equals negative 4. Number 9, x equals 4. We only circle that positive answer as we know that negatives are undefined. Number 10, negative 1 over 16 equals x. Number 11, 7 times log base 4 of x minus 4 times log base 4 of y. Last but not least, number 12, log base 5 of x to the 7th power, y to the 3rd power. And that completes your review with practice. Let's go!